does what it's supposed to do, but there's no guarantee. And then, of course, we require some kind of external acknowledgement of our existence. Someone can collapse the wave function to let us know that we actually exist. This isn't some kind of...
I prefer the alternative.
To non-existence?
Well, I mean, this is all just a simulation. That would be a good alternative.
Well... All right, fine. You want to just start right in on the simulation argument? That's okay. We could do that. All right. So So people have confirmed our existence. So before we get any weirder, I just want to say hi to everybody. Welcome to one of the special guest interviews on Open Space. Today we've got Seth Shostak from the SETI Institute. Hey, Seth. Good to see you again.
Well, it's good to be back here, Fraser. It's although actually, what's disappointing is that I didn't actually have to go anywhere. I could just sit here in my own house as I have been doing for 7 or 8 months now.
You know what I'm looking forward to? I'm looking forward to going places and doing things with people. Yeah. No, that is definitely my experience as well. Just like time has no meaning. The days just blur one into the other. Yesterday is tomorrow. It's all the same. So hopefully, I cannot wait for someone to vaccinate me. Just please, just vaccinate me. Put me out of my misery. Let me go back into society. It'll be great. All right. Well, you know what? We've talked a bunch of times, I think, but for people who don't know, who are you? What do you do?
Okay. Well, my name is Seth. You've already heard that, SETH, and I work for the SETI Institute. That's SETI, which is close to my name.
Yeah.
Yeah. Coincidence. But the SETI Institute is interested in life in space. In particular, there's the SETI experiment, but that used to be the only kind of research that was done there. That's quite the opposite of the current situation now. Most of the scientists working at the SETI Institute today are doing astrobiology. So they're interested in life in space, but it might be microbes on Mars, or maybe life floating in the acidic clouds of Venus, that kind of thing.
You've been playing a long game, and I've mentioned this to you personally in the past. I don't know if I've mentioned it here on the show, but when I first got started in space journalism, I reached out to a bunch of people to get advice and just sort of connect with the community. And this was literally 21 years ago now. And you were one of the people, and Alan Boyle from Cosmic Log back in the day, and a bunch of other people, Phil Plate. And you're all so nice. You're all so welcoming, and and it was really inspiring. And it has served as the template for how I have attempted to welcome every wannabe science communicator into the field as well, which is just like anyone who wants to try to get out there and explain and help and communicate the science to anyone who's listening is all right in my book, and anything that I can do to help them out, I'm right there for them. So thank you, just like for everything you've done for me and for the community in general.
Well, come on now, I mean, to say that I was nice, nobody has ever.
Don't make me look up the email. That I can find this email, and it is delightful from 20 years ago. So,
well, maybe I was nice then.
Yeah, maybe, yeah. It could turn horrible in this very 1 hour. So we'll find out. But you back in the day, SETI was a non-starter for a lot of the scientific community, and now everybody is a SETI researcher. There's astrobiology is a very serious, well-regarded field at this point. There are telescopes that are going to have astrobiology capabilities built into them. There are spacecraft flying to Mars right now. They're going to help with astrobiology. There are it's sort of making its way into almost every field. How does it feel to have been, so early onto this quite exciting field?
Well, I don't know. The bottom line, in a way, is that despite all the effort, we still haven't found any biology beyond Earth. Well, so sure. In a way, you can say that's a bit of a bummer, despite the effort. But on the other hand, the good news is that people are taking it seriously. I mean, what you say is certainly true. I think in astrobiology, maybe less so than with SETI, because SETI requires that extra step that it's not just alive, it's alive, Jim, but the fact that, it's also intelligent and can build a radio transmitter. That's another step, which might be a difficult step. So that was regarded very skeptically at the beginning when Frank Drake did his first experiment back in 1960. He was very careful not to spend very much money, not to spend very much telescope time, just to sort of establish the field because of the skepticism of much of the science community. But that's largely gone now.
Yeah, it really, I've watched it and reported on it year after year after year, and it's gone from nobody wants to talk about it, but off the record, people are excited about it, to very official, money being spent, even out of NASA, for various versions of this. And so I think the plucky SETI Institute had to gather, find a wealthy benefactor to help build a telescope just to do this work. And now there's, I think, more telescopes that are sometimes setting aside some time for SETI, and even, more wealthy benefactors, people like Yuri Milner and stuff, who are stepping up and being able to provide more funds into this. So I think I wouldn't say it's the golden age yet, but it feels like it's SETI's been able to come out of the shadows now, and now I think, start to get some serious work done with a lot of powerful resources. Is my
no longer the lead age. Well, that's certainly true what you say, and I think people were always interested in the idea of life beyond Earth. I mean, that's a very old interest. Certainly goes back to classical Greek and Roman thought. I mean, people were thinking about it. They didn't have the science to actually look, but we do. So that's exciting. But I think that people were always interested in it. I mean,
I agree.
Just think of all the aliens in the movies, right? Or the interest in UFOs. Their interest in the UFOs is probably less in the exact technology of how they light the interiors of their spacecraft or anything like that. Yeah. It's the fact that you have somebody from a different world that's come here. That idea is a very appealing one. And in the science community, finding life is very appealing. I mean, think of which planet, beyond the moon, which planet has been visited the most by our spacecraft? And of course, it's Mars. And is it because scientists are really interested in the lack of plate tectonics on Mars? And no, it's just that Mars might, in fact, have some indication that it has or once had life.
Yeah, it's the best place to look. But and I think what we've seen is, in this sort of new flowering of excitement about SETI, we've seen a lot of ideas come forward, both in terms of searching for exotic form, redefining what life might look like by finding very exotic life forms here on Earth, as well as finding liquid water in a lot of places. I mean, up until 20 years ago, the only place we really thought there was liquid water was maybe Mars, but we didn't know. We knew it was at the poles of Mars, but we didn't know if it was subsurface. And now liquid water is everywhere we can even think about. And so suddenly you've gone from this one possible long shot to a really target-rich environment.
Yeah, it's true. And no, there is, I mean, the universe is kind of inundated with water.
Yeah.
Although I guess that word says it all. But
yeah.
You're quite right. And people sometimes will ask, why is that? And I don't think it's actually all that surprising when you consider that, 3/4 of the universe is hydrogen, at least by weight. And the third most popular, most common element is oxygen. So if you have a lot of oxygen and a lot of hydrogen, you get a lot of water.
Yeah. Now you have, in the past, I know you put a lot of work into the radio side of things. Are you kind of shifting your approach at all? Do you think that radio is still one of the best ways to find a signal?
Well, I do. I still very much in favor of the radio search. And one thing about radio is that it can be unambiguous. I just have to say, I wrote a paper that was published a month or two ago in the International Journal of Astrobiology about looking for artifacts. That's just something that ET has built.
Yeah.
And the advantage of looking for that, of course, is that you don't require that the aliens are sending a signal, be it radio or lasers or whatever, a signal that reaches you just at the time that you're looking, right? If they have something gigantic that they built, or maybe they've rearranged their star system or done something.
Yeah.
I mean, if they're a million or a billion years more advanced, and which they could be, by the way, well, maybe they've done something like that. And if they have, maybe you can see that. And maybe they're long gone.
Mm-hmm.
Maybe they, all died of boredom or who knows what.
Yeah.
Are self-destructed if you're of that mindset. So I do think that looking for artifacts is a good way to go. The only thing is, it's a little unclear what to look for.
But I think you're right that the advantage of radio is that it is unambiguous, that there are certain frequencies that could be coming in the radio spectrum that there is no other explanation than some artificial signal is generating them.
Yeah, that's true. I mean, that's what we look for, not so much the frequencies, there's some frequencies that you prefer, but that if a signal is at only one spot on the spectrum, right? If it's a narrow band frequency and it's only at, 1683.058 megahertz or whatever, right? Then you say, well, nature doesn't seem to make signals like that.
Yeah.
So that must be somebody's transmitter. In that sense, it's unambiguous.
Right. And I think, we're seeing the downside of an ambiguous signal with the discovery of phosphine on Venus, because you've got this one chemical that is actually fairly common in the universe, very common in giant stars like Saturn and Jupiter. So, but yet, in a hydrogen poor environment like Venus, it's quite exciting because we can only think of biology or none of the abiotic processes that are working on Venus can help explain it. But it still feels super ambiguous to me. And in fact, the most likely solution is going to turn out to be some abiotic process that we didn't know. And now we will have discovered it. While you could get that message on, Jill Tarter can pick up the message on a radio telescope and boom, no question, there's aliens there.
Well, I think people will question it, but in general, I absolutely agree with you there. Yeah, the phosphine story is interesting, but it's true. I mean, even the people who published the paper, talked to at least a couple of them, and they are very careful to say, look, we're not claiming life.
Yeah.
What we found is the phosphine, and I certainly believe that if you look at the data, they have found phosphine. But okay, but is it phosphine produced by biology or, as you say, some abiotic process? And you can make phosphine, with volcanoes. Those do make some phosphine. But if you, just sort of do the numbers, the very simple numbers in a way, how many volcanoes you need
mm-hmm.
in order to produce the observed amount of phosphine, it turns out that, it's the entire planet has to be pockmarked with
right.
volcanoes to get enough phosphine. So here's your choice. Either it really is floating life, or we don't understand enough of the geological processes that could make phosphine.
But either one of those is exciting because to discover an abiotic geological process that can generate large amounts of phosphine, I'm sure would keep the geologists very happy. It would make a few astrobiologists a little disappointed, but still. But I've mentioned this a couple of times, that having a place that we can make these kinds of observations and then send a balloon and float around in the atmosphere and double check them is incredibly exciting. That there's no way, if we detected phosphine for the first time with the James Webb Space Telescope on a planet orbiting another star, that would be pretty much the beginning and the end of the story, because there would be no way to double check it. And so we're so fortunate that we have this world that we can go, we make these biosignature discoveries, and Mars too, and then we can go and double check them and go, oh, found the abiotic okay, strike that off the list. Keep moving down the list.
Yeah, no, you're quite right. I remember a talk by Sarah Seeger. She's one of the people, by the way, on the phosphine paper. She's at MIT, and she works on what are called biosignatures, which are not the things you'll see on your paycheck. A biosignature is just, some indication in the atmosphere of a planet that there's biology down there. And, sort of characterized the problem this way. She said that the difficulty is that the very compounds that would indicate biology are pretty much the same compounds that are made by geology.
Yes.
So,
Yeah.
so you're kind of stuck there.
Yeah.
But these
Yeah.
people are clever. So.
Well, they're clever, and it, like back in the day, it really felt like, oh, all you had to do was find oxygen or ozone or methane or something in the atmosphere, and then they just keep finding a natural mechanism that does this. And so it really, like, big surprise, it's going to be complicated. And making the case that you are indeed seeing a signal of life is going to be a lot of work to say, like, we're seeing this amount of methane, and we're seeing these chemicals at this side of the chemical signatures and those ones over there on the spectrum, and we're seeing infrared light in a certain way, and so on, right? But back to you folks with your radio telescopes, you're just like, yep, aliens. So I can see how it's.
I hope you're right.
I do
hope
too.
it's that unambiguous.
Yeah. Now, there's a great question that I actually really like this. T. Holmes says, does it strike you as funny that everyone was skeptical of SETI back in the day, but less skeptical now, though the evidence is looking like there's nobody out there?
Yeah, well, that's an interesting question. I don't think it's actually quite the way it's described in the question. It is true that people, I don't know that they were skeptical. They just thought, maybe it's not science, or I don't know. But it was a delicate, if you will, a delicate topic 60 years ago, and it's not. It's not a delicate topic anymore. Part of that is, I think the change is the fact that we found that planets are so gosh darn plentiful. You've got all this real estate there, and it becomes a little uncomfortable if you say, well, yeah, 1 trillion planets in the Milky Way, but, only Earth has got anything interesting. That, you should be skeptical when anybody says, you're really special.
Yeah.
I've not had the experience of anybody saying that, but, indeed, one should be careful. But it doesn't mean that nobody's out there. The fact that SETI hasn't found anything any more than it means that there's no life in the solar system because we haven't yet found it. We found these, tantalizing clues, but nothing compelling yet. But that doesn't mean it isn't there. It just means the experiment has to get better.
And so from your perspective now, when you look at all of the active work that's being done right now, as well as the potential ideas that are like physically possible, maybe haven't been implemented yet, like say the Square Kilometre Array or the LUVOIR telescope, what do you think is going to be the most productive instrument or methodology to take us closer to this answer?
That's hard to say. I mean, most productive to begin with, what does that even mean? If you say, well,
confirmation or non-confirmation, if you can
make a discovery
or a non-discovery. I mean, a non-discovery is a negative result is still.
Nah, it doesn't mean so much in this field. If you have a negative result, that might just mean you didn't look in the right place at the right time with the right instrument. It could easily mean that. So if you don't find anything, it really doesn't mean anything. I mean, it's like saying, well, I went on that blind date last week and it was a total washout, right?
Well,
but it doesn't mean that there isn't somebody out there.
Sure, but I mean, you can go to Mars and you can say, I don't see any trees. I don't see any dinosaurs roaming around. I don't see any animals. I don't see any mice. I don't see any bugs. Maybe what's left is bacteria, and so you are constraining what's possible, because a long time ago people thought, oh yeah, no, we could see life forms on Venus, and once we peer through the clouds, and that's not the case anymore, right? Yeah, so I think that you can
probably not.
I mean, I'll give you an example of something that I really like. For example, the LUVOIR telescope, right? I've mentioned this quote many times that when the LUVOIR telescope comes online, it will be able to perceive the atmospheres of planets far enough away that essentially if it doesn't see the biosignatures that we will hope have shown up at that point, it will, statistically speaking, give you about a 90% certainty that the Milky Way is devoid of those biosignatures. And so, you could say, okay, we need more a bigger statistical, it's just a chance, and we're not looking for the right kind of life, and so on and so forth. But after a while, you're like, if I don't see anything, maybe we're alone.
Well, I don't see that happening. Look, the number of planetary systems is on the order of 10 to the 11th, let's say 100 billion.
Yeah.
Okay. So 1,000 billion planets, but 100 billion star systems that have these. If 1 in a million of them has life that we can detect, right? Okay, that's still a lot of them, but it means that in order to find an indication of life, you have to look at a very big sample. And keep in mind that the telescopes we're talking about now, James Webb and LUVOIR and so forth and so on, they can look for biosignatures, oxygen, methane, all these kinds of gases that we think are indicators of biology. They can look at for that in the atmospheres of maybe 50 planets, maybe 100 planets. I mean, let's give them the benefit of the doubt, maybe 1,000 planets. Yep. But that might still be too small a sample. Yeah. I don't think anybody would say, okay, that's it, Bob. We're alone here.
Well, I think, I don't want to, we don't need to argue the Fermi paradox today, but, I find either answer to the Fermi paradox one of the most important questions that humanity can possibly ask, and definitely worth putting energy into. So, I think that it is worth our time to search and find what we find. And we may find the answer we're hoping for. We may find the answer that we weren't hoping for, whichever answer you prefer. And either way, as Arthur C. Clarke said, either the universe, either we're alone in the universe or we're not. And each answer is equally terrifying. It is a noble pursuit. I would love to throw some questions that we're getting from the chat your way, because normally I just hog the time. So, all right. So Neil Yu, who is a regular contributor here in the community, is really excited about the Nimitz encounters and the, and I know you mentioned this recently. What is your current feelings on the state of U.S. Air Force military, release of videos and interest in UFOs?
Well, there's endless interest in UFOs, and that's understandable. You've already pointed out the fact that we're always interested in life beyond Earth.
That's all we talk about. Yeah.
Right. Nobody seems to be talking about geomorphic landforms on Pluto or something. But in any case, yeah, the UFO story. Well, they're certainly intriguing. I mean, I've looked at those videos, like I think probably everybody who's watching this has looked at them, and they're a little puzzling. Now, there are actually two sorts of videos, as I recall. One is I think they call it the Go Fast video, and you can see the forward-looking camera on these F-18 Hornets that the Navy is flying, and you see, they're infrared cameras, so you're seeing a heat picture of whatever's in front of the camera, in front of the jet, and you see the ocean there because they were flying over the ocean. And then you see this round object sort of shoot by, okay? And you can say, well, it's for real, right? So what is it?
Yeah.
Well, maybe it's, stuffed with aliens, or maybe it really is a balloon. And, of course, your jet is moving at, 400 miles an hour. I don't know quite how fast they were moving. But, so it goes by. There's just a parallax effect. And so the balloon looks like it's shooting in the opposite direction. That would explain that particular video.
Yep.
That would be somewhat disappointing if you found out that, it was just a balloon. But the more interesting ones, I think, at least for me, are the, what are they called? The Tic Tac videos and so forth, where you see something that looks like a peanut, this black peanut, and then it rotates a little bit and then does this, that, and the other. Now, maybe, again, it's alien craft, but remember, these are infrared cameras.
Yep.
And if you had a plane, a twin-engine jet, that was 1 mile or 2 miles in front of the Navy jet, you look at it with an infrared camera, you would get this double blob because you're just looking at the hot exhaust from the jet engines. And that would pretty much explain it. The motions and so forth I've heard from some former military pilots could be an artifact of the tracking system in the camera. Bottom line, this is probably not making anybody happy, but what I find is when people send me photos, and they do just about every day, of things they've seen in the sky, and I say, well, actually, what that is, and I give them, that's your autofocus, or that's internal reflection in the
Yeah,
lens.
yeah.
Nobody comes back to me and says, thanks a lot. I really appreciate that.
Yeah.
No, they don't. But the bottom line is simply this: the Navy videos are certainly intriguing, but because you can already think of things they could be that are not aliens,
Yes.
then you're caught in this Occam's razor kind of argument. Aliens, or a twin engine jet,
or a
aliens,
balloon, or
balloon, whatever.
Yeah.
And so, in that circumstance, you can't say that the case for aliens, much though you might prefer it, is proven. It's just one possibility, and it's one that requires the assumption that the aliens have come, who knows how many dozens of light years, just to tease the top guns in the Navy.
Right. I mean, I think that the best we can do with the evidence that exists is to say it's unidentified. It's beautifully described by the U part of it's fulfilling all three parts of the UFO name. And that's where this conversation has to end. And you may be interested and excited about unidentified things, but just by the name, you've got to stop the inquiry until more evidence is able to be acquired. And so then I think it's an argument of like, is it worth attempting to acquire more data on this kind of situation? I mean, that's where I think the rubber kind of hits the road, is like, do we spend scarce resources scanning the skies for moving objects and attempting to figure out what they are, which people do, or do you spend them in building radio telescopes attempting to receive signals from aliens, or do you attempt them to build spaceships that are going to go to search for life on Mars? I mean, it's just, and yeah, absolutely. If someone can introduce me to their alien friend, and I can check out their spaceship, and I can, as Neil deGrasse Tyson always says, just borrow a hyperspanner for the day, we'll get to the bottom of this right away.
Yeah, I don't think it's an either or situation either, though. I mean, you can do all of that, and spending big money to try and find these things, if that's your predilection, you don't really need to, in the sense that we already have 750 satellites, operational satellites, that are looking down toward the Earth. That's to leave aside all the communication satellites and the space telescopes and all that. So there are already 750 satellites, and on average, every day they photograph every square mile of Earth's surface, including the oceans, by the way.
Yeah.
So if there's something flying around that the FAA doesn't know about, you would think that these cameras would find them. And if you say, oh, well, they are, but that's all being suppressed, then you're resorting to, I think, an untenable position where you're saying, oh, it's for real, but it's all being kept secret. And that just doesn't fly, even though that's kind of a bad pun.
Yeah. And so I think it's just really important to draw that line and to just say, okay, unidentified. I don't know what that was. Let's talk about something else now. Because until someone can provide any additional data, you have to stop the conversation. But to make the leap to say, I don't know what that is, therefore I know what it is, that's a step too far.
Yeah, as Popeye used to say, you've jumped to seclusions.
So Christian Woodland asks, would it make sense to scan for Earth life from a far-off area in space to see if we can detect such? So what do you think about classifying the Earth as an exoplanet? Is there value to that?
Well, it's an exoplanet to everybody else.
Yeah.
Well, in a sense, people have done this, or at least they've done it on paper. They have done very little for real. We've made photographs, obviously, of the Earth. And, you can look at the photos made from the moon or halfway to the moon. It's very obvious that the Earth is a little different than the other planets in our solar system, right? It has liquid oceans, and it's got continents and clouds and weather and atmosphere and all that stuff. That you can do. But could you detect the life on Earth from space? Well, I mean, even if you were light years away and you had a really good telescope, you might be able to do that, because you would see the color that's being reflected by the Earth. And you would notice that it changes as the Earth orbits the sun. Because, in the winter, the trees lose their leaves, whatever. a lot of the green is gone in one hemisphere and it's increased in the other hemisphere. You might be able to tease that out of the data, depending on how good your telescope was. Obviously, you could also pretty easily measure the oxygen, and that would tell you, oh, well, there's something there making oxygen, and that's, your house plants, but also a lot of bacteria in the ocean, so, that you could do. If you were within 75 light years of Earth, of course, you could tune in our early radars and television and FM radio. So, but nobody has done this because it's, an experiment you can do with pencil and paper. You don't have to actually send a receiver out into space and say, could you pick up the Earth?
Right.
I mean, you know whether you could or not, and it would depend on how good a setup you had at the receiving end.
Well, there's a wonderful experiment where I think was it Galileo spacecraft, when it flew past the Earth, took a picture of the Earth, and Carl Sagan wrote a paper that Galileo had detected life on a planet, and sort of provided all of this information about all of the indicators. And so I think if you're standing on the surface of this other world, and you're looking around, you're able to determine whether there's life or not. And if you're looking down from orbit, it gets a little harder, but maybe you can still do it. And as you keep going farther and farther away, it just gets tougher to make a more conclusive case that yes, indeed, there is life there. And then eventually your ability to detect these things just start to fall over this horizon, and it's more and more difficult to be able to just make any kind of conclusive evidence. And that's...
Yeah, no, distance is not your friend, obviously.
Yeah. But the trick is just make a bigger telescope, obviously.
Yeah, well, that exactly right. I mean, I just for the fun of it, worked out if you could build a telescope that was, many miles across. That's not something we're going to build, but, we build telescopes that are a lot bigger than what Galileo had 400 years ago. And 400 years ago, 400 years is not very long. I personally find it a long time to wait for anything, but 400 years is not terribly long. So what kind of telescope would a society that's a million years more advanced than we are have? And if they can build something really big, then they can actually make pictures of worlds very far away. And, if you do that, you might notice things. Yeah.
So Rejects asks, what would a definitive Venus mission look like? Would it have to be sample return? If you wanted to...
I don't think so.
No?
I mean, if you say we want to find out whether the phosphine in the atmosphere of Venus is due to biology, and by the way, there are other indicators that might bear on this. The fact that there are certain absorption lines in the, I think they're in the ultraviolet, but I may be wrong, maybe the infrared, but in any case, not the visible. Certain absorption lines of the Venusian atmosphere that are known, where, certain parts of the spectrum of the light from the sun that's falling on the Venusian atmosphere gets absorbed, okay? And it doesn't seem to be just the consequence of the atmosphere itself, that there is some component of the atmosphere that's absorbing these wavelengths of light, and as it turns out, little microscopic plants might do that. So there is all this stuff. But I think that if you want to determine whether there's life, buoyant life in the Venusian atmosphere, yeah, you got to send something through the atmosphere. It would be good to do what you were suggesting, which is, just have a balloon, because then you could hang out at the right altitude and spend some time doing it. I don't think you'd have to bring anything back.
Right.
If you have, a clever experiment. I mean,
as long as it's got a windshield, then bugs will splat into it and it should be fine.
Bugs, yeah. That'd be good. Venusian insects. There was a movie made in the 1950s.
Yeah.
I think it was a made-for-TV movie called Zontar, Thing from Venus. And, he looked like your ASA standard alien, actually.
Was this before Mariner 10? Probably
yes.
would have been, yeah.
Yes,
1970s or
I don't
so.
think that would have dissuaded the producers.
Yeah, probably not. Yeah. I remember there was was it a Ray Bradbury story or something like that about some kid who lived on the Venusian colony. It rained for years and years and years, and then the one day when it stopped raining, he got locked in a cabinet while his friends all went out and got to play in the sunshine for the one day every 20 years that it remains sunny, and then they found him inside. He'd been, bullies had locked him, and then he came back and then it started to rain again, and he missed his chance to enjoy sunshine. So that's what they thought back in the 1950s.
Yeah, well, I mean, much more recently than that, the checkout line press had stories about the dinosaurs on Venus.
Right, right.
Yeah.
Well, 90% the gravity of Earth. You can have much larger creatures there. Um, Manimus11 asks, what about a telescope on the moon? Would that work to find something? This is a layup. Tell us about how wonderful the moon is for SETI.
Well, I mean, the moon, I don't know that it's been that wonderful. And when I look over the donations to fund the SETI effort, very few of them have come from the moon. But
Nope.
there is a point here.
Yeah.
There's a point here, and it's a good one. Obviously, the moon doesn't have any atmosphere. So if you put an optical telescope, mirrors and lenses on the moon, you get a dark sky all the time. Oh, the sun is over there, but it doesn't matter. You can still look at the stars over here because there's no atmosphere. And so there's that. And people talk about putting observatories on the moon, but you can also put them in space. But when it comes to radio telescopes, they tend to be very big. The bigger is the better, right? So, the biggest radio telescope is the single dish is the fast radio telescope in China, yeah, which I think is 500 meters in diameter. So, that's pretty big. And you can't put that on a satellite and launch it, right? So, something like that, though, you could put on the moon. And the big advantage for SETI would be to put something on the far side of the moon, the back side of the moon, because back as seen from here, because that's one place in the universe that is permanently, shielded from all the interference that we make, all our transmitters and, all the electronic noise we make here, which can mess up any attempt to find a signal from ET. So the backside of the moon, if you happen to have the wherewithal to fund that kind of a project, I mean, you should really get in touch.
Yeah. I mean, there's been, Beth was just mentioning in the chat that we just have a story we just posted on Universe Today about that. And, I'm doing my part for the cause. Every time I see a paper that I think is interesting, I task a writer to get a story up on Universe Today about this and there's some absolutely fascinating ideas. One that I really liked is sort of akin to the Murchison Array in Australia, where they have like a rover that lands, or like a lander, and then a rover comes out and then just lays out the same kind of antenna over an enormous size on the far side of the moon, so that you could actually have this quiet place. One of the capabilities of a thing like that, for example, would be it would be able to detect magnetospheres of extrasolar planets as they're interacting with solar flares from the star. So you would be able to go straight to, there's a planet in the habitable zone with a magnetosphere that's protecting life on the planet, if there is life on the planet. Not to mention, seeing the 21 centimeter line at the beginning of the universe and being able to probe the cosmic dark ages, but more importantly, magnetospheres and other things. So yeah, I cannot wait until somebody finally commits and puts a radio telescope on the moon. Not necessarily a gigantic dish. I think there's some pretty interesting ideas just to drive around and drop antennas. And if you build a big enough array, you've got yourself a powerful interferometer and you're good to go.
Yeah, well, obviously the scheme you just described, where you just essentially lay wire across the moon, that'll work for low frequency radio reception.
Yep.
Obviously it doesn't work so well at microwaves, but yeah, you could do that. I think that would be pretty good. It might ask for union wages.
The robot. Yeah.
I mean, there are other problems too. You also have to figure out how to get whatever data you're collecting from the backside of the moon back to Earth.
Well, the Chinese solved this. They already have a spacecraft in the Moon L2 Lagrange point retransmitting data from the surface. And it's a radio telescope. So I think we're there, that's been solved. That's a solved problem.
L2 doesn't sound right, but yes, you could do that. But then you also have to build the relay satellite. I mean,
yeah,
the cost just goes up.
And well, no, but I mean, there's already a radio satellite there right now. There's a Dutch radio telescope on board, and then there's from the Chinese satellite, and in fact, there's another one in the works to do. I think like next year, 2 years from now, another radio telescope is going to go to the L2, but in space, not on the surface. So, let's see. So Arjun asks, could we eventually tell if a planet had different environments, like moist areas, dry areas? Most planets seem to not have much variation. Maybe variation is a key to life. So could we detect variation?
Well, again, if you have a big enough telescope, you can find anything you want. But the kind of things that you're likely to do over the course of the next decade or two, if you find a planet, here's a really simple experiment. You just monitor the amount of light coming from that planet, if you can do that. That's hard because now you've got to collect enough light from the planet to at least illuminate 1 pixel on your camera.
Ignoring the star.
Yeah, exactly. We found 4,500 or so planets, but almost none of them has ever been seen. Right? They've been found by indirect methods. They cross in front of their star, or they cause the star to wobble and all that kind of stuff. So you need a telescope that's good enough, which is to say big enough, to actually see the planet. Actually, it doesn't have to be so big, but it has to be really good about blocking the light from the host star. That's a tricky thing. But if you can get that light, if you can get 1 pixel's worth of light, then all you do is you just sort of look at it as the planet goes around a star. You look at it over the course of days or a week, and you see if the amount of light coming back from it is varying. If you did that for Earth, you'd notice, well, every 24 hours it goes through a cycle where the brightness kind of dims, and then it gets brighter again, and it dims because of the rotation of the Earth. So sometimes you're looking at bright parts of the Earth, maybe the continents, and then the rest of the time you're looking at the dark oceans. So that kind of thing is not very hard to do if you can actually see the planet.
Right. As long as you've got a gigantic telescope, you're capable of blocking the light from the star, then you could see that variation of like continents versus oceans.
Yeah. Actually, it doesn't have to be that big a telescope. It isn't a matter of collecting enough light, actually. It's mostly a matter of the fact that the planet, as seen from here on Earth, that planet is very, very close to the star, right? Yeah. And so you think, oh, well, okay, so you see the star, and then you see the planet next to it. But, telescopes always have slight imperfections, and the diffraction of light is another problem. And so the light from the star being, maybe billions of times, literally billions of times brighter than the planet, all these imperfections scatter some of the starlight and block your view of the planet. That's what makes it hard. It isn't so much that the telescope has to be huge as the fact that it has to have what's called a very high dynamic range.
Right. Yeah. I mean, and that's sort of the other thing that I really love to sort of task writers on Universe Today with is just clever ideas like that. I remember someone proposing, we could see seasonal variations. So maybe we could see the northern polar caps increasing and then decreasing, and that would change the colors coming from the planet over multiple years.
Yeah.
Assuming you can, and there was one that just came out, someone proposed like you could see the shadows of trees because it would just change the nature of the light depending on the time of the day. It would make the light coming from the planet, like I think the polarization of the light. I forget exactly what they were going at, but it would just, the shadows look different from the sharp features from just the moon, like Rocky Mountains, as opposed to the sort of the trees on the surface instead. And I hear a million of these ideas and I love them. And each one you're like, God, I wish someone would just give you a great big telescope so you could just check. And
well, one idea that's been bandied around for quite a while now is gravitational lensing.
Mm-hmm.
Right? This is just a consequence of relativity, really. But any massive object, any object which has mass, which includes this flea over here, anything that has mass will bend light a little bit. Now, the flea is not bending light very much. The sun, however, bends starlight. So if you're looking at a star that's right near the edge of the sun, it will seem to shift in position by a couple of seconds of arc. It isn't very much. But that effect allows you, in principle, to use a big, massive object like the sun as a big lens, to collect light. Now, the problem is that the focus that you need to go to in order to use that is, 10 times, maybe more.
It's 1,000 AU.
Yeah, well, 500 is the starting point.
Yeah,
and
starting
1,000
point
is probably what you need.
Yeah.
But, 1,000 AU, okay, that's That's what is it? 1,100 million miles. That's long. But you could put a satellite out there. It might take you years to get it there, but you could do it. The
Yep.
only trouble is then you're only looking in one direction because you look at the sun.
Yeah.
But anyhow, all that aside, nobody cares about all of that. But if you just do the calculations I actually did once, could you use a telescope like that to see the city lights from a city the size of Los Angeles from 100 light years away? And the answer was, yeah, pretty much. Pretty much. So maybe that would be the way to go.
See, so now we're back to just give these people a bigger telescope or a more
Yeah.
powerful telescope that can get this job done. Because it's that same idea. You talk to astronauts and they say, "Oh yeah, the Earth in the daytime, it's hard to see any examples of human civilization, but you see at night and it is stark. Like there's no question the impact that humanity is having on our planet with all of the lights. And in fact, you can even tell who's got money and who doesn't have money just by where the lights are located and where people live and don't live. So it's pretty fascinating. This is a question that I get that I figure I would throw your way is, in searching for the radio spectrum, people always ask me this question, like, and I'm sure you've gotten it a million times as well, which is like, how do we know that aliens are still using radio communications to talk? Maybe they've transcended to neutrinos or whatever, man. So, how do you respond to that?
Yeah. Well, it's true. Maybe they use, subspace communication. Isn't that what they use in Star Trek?
Yeah.
I've never known what that is, but it certainly sounds good. Subspace communication to me always meant talking to the guy next to you on the subway platform in Queens, but I don't know. All right. So why would they be using radio? It's so old school. But yeah, it's old school, but many things are old school, right? The fact that we're still using, eyeballs to look at the world is because you get a lot of information from light, from this electromagnetic radiation. So I think that any society that's technically sophisticated, yeah, you can expect that they will have invented the wheel. We still use that. It's pretty old. But they will also have invented radio, lasers, because you can send lots of bits of information with these technologies, and you can send them at the fastest speed that, seems to be possible, which of course is the speed of light. You can't send information faster than that, at least according to Al Einstein, and he seems to be right about most things. So I think that it's as predictable as saying, well, will they have the wheel? I really think it's very likely they'll use it. They won't use it for the same things we use it for. It won't be all talk radio or top 40 or who knows what, but they will use the technology. They will use this ability of the universe to convey information across very, very vast distances, even light years, if you really want to do that. With a relatively simple technology. Neutrinos sound good, but neutrinos, you take a single neutrino if you can get your hands on it. A single neutrino, it takes a lot of energy to make a neutrino. And it's also very hard to detect them because they just go through everything, right? I mean, your head is just seen a trillion neutrinos per second go through your head, right? And because nothing stops them, fortunately, it doesn't really decrease your IQ. So neutrinos are good, but they're hard to make. They cost a lot of money to make the energy in order to make a neutrino. And they're also very hard to detect. I mean, if you look at the big neutrino detectors on Earth, they're huge. They're like a kilometer across. A radio transmitter receiver, that's very much smaller, and the information goes just as fast, in fact, faster.
When people talk about the Fermi paradox, and they, the question is not why don't we detect anybody, because obviously the universe is big and the universe is old, and the moment life started on Earth, it did. The question that Fermi was really asking is, well, where are they? Why haven't they traveled to here? Which is, I guess, back to the UFO question. So what answer is your favorite for the Fermi paradox?
No, I don't think I have a really favorite. I mean, as you know, there have been entire books written about the Fermi paradox.
Of course. Yeah.
And the basis for Fermi's, question, where is everybody, was simply that the amount of time it would take for an advanced society, even if they had rockets that were only 100 times faster than ours or 1,000 times, that's possible to do. For them to colonize every star system in the galaxy is 30, 40, 50 million years, which is very short compared to the age of the galaxy. So the point is, if somebody out there wanted to colonize the galaxy, if one society wanted to do that, they don't, you don't require them all to do it. If one decided to do it, they've had time to do it. But, colonizing things, I mean, there's been plenty of experience with colonization here on Earth, and you do it for a couple of 100 years, but you don't do it forever. You run out of resources, or the colonists begin to fight back, or there's competition from somebody else, or you just decide, instead of spending the money to do that, let's provide everybody with, I don't know, the latest video game. I don't know what they're going to do. But the fact that you don't see aliens everywhere doesn't mean there aren't aliens everywhere. It just means you don't see them.
Mm-hmm.
And I just don't think that's terribly compelling.
Interesting. I find it personally. I find it harrowing, and mind bending. But I can totally respect that you don't want to.
Well,
that it doesn't.
Let me give you an example of something. This has been suggested as an explanation for the Fermi paradox, and that is that the galaxy is urbanized, and there are some parts of the galaxy where there's just there's a lot of activity, and there are colonists everywhere, and there's the Federation of Planets, and Captain Kirk gets to dry clean his outfit or whatever.
Yeah.
So you have that part of the galaxy, but a lot of the rest of the galaxy is sort of like the outback in Australia, right? You go 200 miles west of Sydney, and there aren't many people, right? There really aren't. And so maybe that's where we are. We're in a part of the galaxy. Obviously, if there were aliens here, maybe they would have suppressed whatever was happening on Earth, 4 billion years ago to give a rise to life. And so obviously, if we're going to be asking this question, and the very fact that we're here to ask that question suggests that we're in a backwater. Either that or there's just nobody out there.
Right. Okay.
That's my off-the-cuff answer.
Well, I think, that's fine then. I mean, I think that is your response, and I think that's great. I mean, I think that at least, at the very best, we are in the backwater edge of the galaxy, that we have not been invited to the party yet. So,
yeah, well,
so we have to shove our way into the party, I think, is the point here.
Well, what's the dress code? That's what I want to know.
Bring a telescope, I guess. T-Home asks, given what we know today, what factor of the Drake equation do you think restricts the chances of alien life the most?
Well, I'm sorry that my answers to all these questions is the same answer. Namely, I don't know. But there are some factors there in the Drake equation that are routinely singled out as being problematic. Certainly the last factor, L. How long does an intelligent society last?
Yeah.
And, particularly millennials seem to be really hard over about the fact that we're going to wipe ourselves out. I mean, there are all sorts of challenges: nuclear weapons, climate change, pandemics, you name it. We've got a dystopian future for all of you.
Yeah.
But I'm old enough to be still optimistic. I don't think that explains why we're not finding anybody. But so that's that term. It may be that as soon as you've developed transmitters and you can be found by a SETI experiment, within 100 years, you use all your nuclear weapons and just wipe everybody out. It's actually quite hard to wipe everybody out, by the way, if you're thinking of doing it this weekend. But there are other problematic questions. Just because you have a lot of life doesn't mean you ever get the kind of life that can figure out physics and chemistry and build stuff, right? I mean, Earth has had life for 4 billion years, more or less. And only in the last couple of 100 years have we been able to do that kind of technological advance. So that doesn't, maybe that's a big barrier right there.
It's interesting. I would love to see. We're thinking of running a series again on Universe Today. I know I'm shamelessly self-promoting my project. We'll get to yours in a second, but where we just try to figure out the most comprehensive version of the Drake equation that we can. We're going to ask every scientist to just start brainstorming factors, and my guess is we'll end up with thousands. Like, Does it have a moon? Is the moon tidally locked? Is it a large moon? Does it have a magnetosphere? Does it have, and on and on and on and on. It'd be very interesting to sort of think about, this times that, like based on our current, now our new knowledge. I mean, I'm sure even Drake himself would love to just redo the equation based on what we now know in terms of of science.
Well, I actually asked him that not too long ago.
Okay, all right. Well then,
and the Drake equation was cooked up in 1961 as the agenda for a meeting in Green Bank, West Virginia, and they discussed what they thought the values of the various terms in the equation were, and their knowledge was not as good as our knowledge today. We know, for example, what fraction of stars have planets, and we even have some idea what fraction of those planets might be habitable. They didn't have any of that. Nonetheless, their estimates for all the Drake equation parameters that we now know better, right, were about the same.
Right.
They weren't any different, even though they didn't really know.
Right.
They guessed. They were good guessers. These were smart people. Yeah. So I asked Frank. He gets emails essentially every week from people who think they have a new factor for the equation, and he's never actually found that necessary. But it's also the case that he doesn't think that the estimate for the number of societies out there that are broadcasting should change very much from what they thought it was in 1961 either.
It is interesting to me how many of the ideas that were proposed back in the 1960s and 70s are still just the kind of the shining pinnacle concepts that we still all wrestle with today. That these giants, Frank Drake and Fermi and Carl Sagan, they planted such incredible ideas in our minds that we've been wrestling with them ever since.
So don't forget the Russians too.
Well, absolutely, yeah, of course, the Kardashev scale.
The Russians were very, very clever. They didn't have enough money to actually build too many telescopes, but they were very smart.
Yeah,
so they came up with a lot of really important ideas.
Really worked hard on getting a spacecraft to the surface of Venus. Like
they did.
If there's one thing they really nailed, it was getting a spacecraft. So I want to talk. We've got a couple of minutes left, but you have a podcast. So if you're enjoying the conversation with Seth, you can hear him go on about these topics, all kinds of new discoveries, anytime you want. So let's talk about your podcast.
Yeah, it's a podcast. It's also a radio show. It's called Big Picture Science. Big Picture Science, and you just Google that. Big Picture Science. You might be able to remember that. It's certainly much easier to remember if you remember it in Hungarian or Icelandic. Big Picture Science, and we cover all science, not just the kind of stuff we're talking about today. So check it out.
That's fantastic. Yeah, and not just the search for life, but just big picture science in general.
Science in general. Yeah, we're talking this week about fungi that because of climate change are beginning to kill people around the world because they've adapted to warmer temperatures, and now they can adapt to 98.6 degrees in a human body.
That's a really important temperature.
Yes.
That sounds absolutely true. And what are you obsessed about right now?
What am I obsessed about?
Yeah. What's
just in general? I mean, are you talking about
just
house?
In general, or about in the world of science? Yeah. I don't know about you. I go down rabbit holes for a while.
Yeah. Well, I've done that. It turns out that the rabbits don't appreciate it. I think obsession. I have many interests, and it's hard to say which one is obsessing me the most. But in terms of science, I think aside from biology, which is very interesting, the other thing is, of course, artificial intelligence. I find that very interesting. And astronomy always. There's always something happening in astronomy every day. There are 3 or 5 stories that come out about astronomical research. I had a history in which I was involved in the study of galaxies, and we found that there was something very heavy in galaxies that nobody could see. It's now called dark matter. So I do tend to follow that a little bit too.
Yeah. The actually artificial intelligence has been making some great strides in planetary science. They just fine-tuned an algorithm to properly find craters on Mars, which has been sort of grad student work for decades, and now suddenly a computer can go and count craters well, and start to reveal some pretty interesting how useful it is to know numbers of craters on Mars and things like that. So we're seeing it in terms of classifications of galaxies. So a lot of this stuff that was the job of a grad student has now become the job of a computer, which is
That's why they're in
wonderful.
the unemployment lines. Yeah.
Yeah. Oh, they'll find jobs. They'll find jobs. Well, Seth, it's been an absolute pleasure to talk to you again. You're humble, but you have created an enormous impact in all of our work and in the science communication field, and I know a lot of people have been inspired by you in the science field as well. I think I can think of few people who have contributed to the field of SETI. A lot of what we just talked about at the beginning, this is due to you. So thank you for all of your contributions. Everyone, if you want to listen to his podcast, his radio show, old-timey radio show, definitely do that as well. And anytime, I always ask, if you ever do find the aliens, please let us know.
I think you'll hear about it.
I want to hear from you. I want to get the advance notice. Yeah.
Yeah. Everybody wants advance notice.
I know.
I may be the last one to know it.
All right. Well, then I'll let you know. All right. Thanks, Seth.
Thanks very much.
Thanks, everybody.